I've got a old harmonic drive motor with 101-to-1 gear ratio, and just go through the basic setup here. It's a brushless rotary. It's got an absolute A format. It's 17 bits, but in this feedback device, we have to ignore 4 bits. It is a 16-bit multi-turn feedback device. So that's the basic setup. And let's take a look at the data that was in this thing. So NFHA-25, well, it's an obsolete, and there's no letter after the 25. So I'm going to say this data that somebody entered must be correct. But the S248-SP for special, maybe, that's an absolute A, but there's 4 ignore bits. So it's really 8192 counts per rev with 65536 multi-turns. It's 2.5 megabit, and I assume there's a battery, but I haven't dived into that because I can't find the data for an obsolete motor. Maybe it's 20 years old. Anyways, you can kind of see the problem with the motor data, like 4,300 volts per K RPM, and you can go 3,200 RPM. So you know that's, something's wrong with the data. But I'm going to say on the surface, it's 61 Newton meters at the output of the gear, and it's 39 Newton meters per amp at the output of the gear. So that's 61 divided by 39 is the current, newtons divided by Newton meters per amp. And you can see the calculated current is 156 amps, and there's some peak there. So this is the challenge for phasing this motor. It's such a large gear ratio, and the continuous current is not sufficient for rotating the current vector. So I enable the drive, 0.16 amps. I try to rotate it. Insufficient current for rotating the current vector. The red is the position. Let's do the full rated current. And still insufficient. So what I have to do is cheat. You can't do 5 amps for long, but you're going to need larger current to be able to phase the motor. So I'm going to give it 5 amps, and now I'm rotating. There's a lag in the red as I rotate the current vector in black. So, and when I go reverse, there's a lag in the red, so it's balanced. I've done a good job phasing. When I came to it, it looked like this. Trying to figure it out. It looked like about 180 degrees. I mean, I tried 60, and there's a wicked lead, so that's not good. 120, still a wicked lead, so 180. The important thing is that it's balanced. So as you rotate the current vector in black, the red needle lags the black. And you can also see the counts were going up as I rotate forward. And the motor is going in, I don't know, hope it's the clockwise direction, but you could invert the motor, but then you'll need to invert the feedback, and then you'll need to change the offset again. So that's the basic instruction for trying to phase a motor that has requires such a large current just to get over the stiction in the motor. Manual phasing, auto phasing, these are not using the optimal position for the current vector, like when you're commutating it. But you can see that to get this to work, you have to bump up the current. Just be careful you don't burn up your motor. So when you're done, put it back to the rated current and then save the flash. So this motor is phased, and before I address the feedback error here, we're going to look at the data for the motor, because the data is, somebody entered it. I'm not saying it's wrong, but it's just not good from the perspective of the motor. So what is the Newton meters of the motor if everything was perfect, I'd divide 60 newtons by 101, and I'd get 0.603, so 0.603 Newton meters. And I'd do the same for the 204 divided by 101, and I got 2.02 Newton meters. This is just the motor at the before the gear. And then the Newton meters per amp, 39 divided by 101, and I got 0.386, so 0.386, and we'll do the same for the 4,300 and divided by 101, and I got 42. Now, there is a general rule which says volts per radians per second equals Newton meters per amp. So there's a little disagreement here. I'm not sure if it's just a problem with the Newton meters per amp being entered in as amps peak or RMS. Typically, when we say the motor is 1.6 amps, the motor might be ARMS, whereas the Copley is amps peak. So let's do the 0.386 here, 0.386, and see what that looks like. Yeah, this will give me a higher current, and the volts per radians per second, 0.2729, and go to volts per kRPM. So it's a little subjective here. If you know some data, that's good. It'll help. But the motor resistance, I measured it more like 2 ohms, and therefore the inductance is more like 6 ohms. The motor manufacturer tends to look at it as a coil, not a pair of wires or phase to phase. So phase to neutral is not the same as phase to phase, and we're concerned about the inductance phase to phase. So this is the more appropriate data. And then if it was 28 volts and I had 200 volts rectified to 0.141, 282 volts. Okay, so divided by 28.58. Yeah, that's kind of crazy fast. I'd put a top speed at theoretically 6,000. That's not the rated speed, and maybe you don't really want to go that fast for your gear, but let's use this corrected data to, I'll save this to a file here because I want to overwrite the old one there. So I got an HD, which HD do I have? Let's just make a new one. There. Yeah, overwrite it. Good. So this is better data. Yeah, so now we get 2.2 amps peak instead of the 1.6 amps RMS. And that's still insufficient for commutation, but the 5 amps isn't going to burn it up for several seconds because this can handle the peak current for several seconds. It's got a pretty high thermal time constant. I got a feedback error. When I get a feedback error, I always like to take a look. Yes, feedback error, but there's an encoder status. PSERR on encoder. I got to look this one up, but that's something to do with the encoder doesn't believe the data it's sending you, so it's going to issue an error. That's a bad encoder, actually. I can't seem to clear it. Anyways, never hot swap, but if you unplug it, give it a second and plug it back in. Oh yeah, you got encoder busy error, CRC error, but now it's gone. I can clear it. And so that was a permanent error in the feedback device. It's not the Copley. Nothing's ever wrong with a Copley, but the feedback device is not doing so good. Anyway, so these new calculated values are a little better for the current loop bandwidths. And I had noticed the gain was a little low with the old values. so we can auto setup. Yeah, look at that. Perfect calculated values. Let's see if we got anything from the velocity. Yeah, now the velocity is working because, yeah, think about it. Like the inertia and the torque constant, those are used to calculate the, if we don't have the right values there, then that'll be a problem. Oh, current limit. Yeah, let's not do that so fast. You see, it takes so much current to move this motor. Let's try it again. Yeah, encoder error. Okay, the purpose of this video is not to show you how to tune things up, but to show you how to phase the motor. I've got some serious problems with my feedback device that I'm going to have to address here before I try to spend any more time tuning this thing. All right, thanks for watching.